Standing by for telemetry acquisition. Phoenix switch to 32K detected. We have data lockup, parachute deployment trigger detected, heat shield trigger detected, ground relative velocity 90 meters per second. Ground relative velocity 80 meters per second. At this point in time, standing by for radar RF on and altitude convergence. Radar switch to altitude mode. Standing by for altitude convergence. Land leg deployment trigger detected. Ground relative velocity 60 meters per second. Standing by for altitude convergence. Radar reliable. Altitude 2,000 meters. Altitude convergence detected. Altitude 1,800 meters, 1,700 meters, 1,600 meters. Standing by for lander separation. Altitude 1,100 meters. Signal may drop out during lander separation. Altitude 1,000 meters. The separation detected. We have reacquired the signal. Gravity turn detected. Altitude 600 meters, 500 meters. 400 meters, 250 meters, 150 meters, 100 meters, 80 meters, 50 meters. Constant velocity phase detected. Altitude 40 meters, 30 meters, 27 meters, 20 meters, 50 meters. Standing by for touchdown. Touchdown signal detected. Landing its sequence initiated. Helium vent detected. Standing by for normal termination of VDR comm.
All right. We have a few of those mission team members to the mission support area back there in the back, including Richard Kornfeld, who got to count us down there all the way to the surface. Okay, now we're going to go up to our panelists, and I want to introduce all of them to you. Of course, joining us today, we have NASA Administrator Mike Griffin. Ed Weiler, NASA's Associate Administrator for the Science Mission Directorate. Charles Alachi, the Director of the Jet Propulsion Laboratory. Peter Smith, you all know by now, but he's the principal investigator for the Phoenix mission from the University of Arizona in Tucson. Barry Goldstein, the Phoenix Project Manager from JPL. And Ed Setevy, the Project Manager from Lockheed Martin Space Systems in Denver. We're going to begin with comments from the administrator.
Thanks very much. I was thinking about what I was going to say tonight, and for some reason, maybe the presence of our various congressmen and elected representatives in the audience cued me in on this, but I was thinking back to a very long time ago, preparing for my first congressional testimony ever. I had all my hair then, and it was black. And I was looking for advice on how to handle it from an older friend who said, well, remember that an expert is a person whose head is full and his hands are empty. He said, experts make it look easy. So don't carry in a whole lot of stuff. and I've tried to follow that rule ever since then, but what stuck with me was experts make it look easy. Well, today you had a chance to watch a team in action making something that is incredibly hard to do look easy. And you know that they are the most expert of the expert when they can do that. I'll just give you one measure of that expertise. Accuracy at entry interface had to be well inside 20 kilometers of error after a 650 kilometer, million kilometer round numbers trip from Earth to Mars, and yet had to be delivered to something like 20 kilometers of accuracy on entering the Martian atmosphere. That's something like fewer than 1 part in 10 million of accuracy. Very few things that human beings do in any walk of life are as precise and accurate as 1 part in 10 million. And that's the kind of accuracy and precision with which navigation is done here at JPL at one of the technical pinnacles of the space business. There will be many more measures of the kind of expertise that have to be applied to pull off what you saw here today, but I won't bore you with them. It's not, I don't want to take up too much time. I want to let these people talk to you about what they've been able to do, but I want you to think about that 1 part in 10 million of accuracy and precision that these folks delivered in order to be able to land the spacecraft on Mars, and think about that. Thanks very much.
Okay.
Thanks, Mike. One thing I wanted to do was recognize all the people that make up this team, especially some international groups which you may not be aware of. Of course, we have the PI and the head of the science team, Peter